Okay, so let's go ahead and click on Lesson 1.3, Worksheet, Special Trig Limit. Like I said, our first exam will be on August 30th. All right, so we have a few days. And I'll definitely give you some type of review worksheet before that day. But your quiz will be based on all limits, table, graphing, direct substitution, simplifying method, which all covered up to this point. Today we're going to go over special trig limits. And then next week we're going to go over rationalizing the numerator method and a couple more. And after that, we'll try to get ready for your exam on 30th. All right? Okay, so here it is. All right, so our first formula is basically this one. This is our first formula. This formula, remember I told you that there are 3 formulas you need to remember? But A and B are basically the same thing, kind of. You see it? There's a subtle difference. They're saying it doesn't matter if you have sine something over something versus something over sine something. Both of them will equal to 1. Only if x approaches to 0. This formula is only true if x is approaching to 0 and x is approaching to 0. You cannot use this formula if you have x is equal to something else. Right, so you need to memorize that. And what do you think they mean by these things right here? They're saying it doesn't matter what you have as a variable, as long as they're matching. You need to match those. You can have an x. If you have a sine x, you need to have an x underneath. If you have a sine y, then you need to have a y underneath. If you have sine xyz, then you need to have xyz at the bottom. Does that make sense? Same thing with the other formula, part B. Make sure they're matching. These are matching. All right, the last formula you need to know is this one. Again, this formula is only true if x is equal to 0 or x is going to 0. And that will give you 0. There's no anywhere like around it. You just need to make sure it is matching. And it's equal to 0. All right, so here you go. Here's the first example. All right, pay attention to me and do not copy anything. Just pay attention to. Here's our first example. This one. You see this part?
Yeah.
Are they matching? No. So we have an issue. But you need to understand from integrated 1, 2, and 3, anything, any number times 1 is equal to, anything times 1 is equal to itself. You guys know that, right? So any fraction can be written, any value, let's say if I have 2 over 2 is equal to 1. 3 over 3 is equal to 1. 4 over 4 is equal to 1. Any number over its same number will equal to 1. Does that make sense? All right, so don't copy this. Just pay attention. You can watch the video over again later. All right, so since this is not matching, we need to come up with a trick. You need to multiply top and bottom by 3 and 3. Why do we pick 3? Because we want to match this 3 right here. Does that make sense? But 3 over 3 is just same thing as 1. Does everyone understand that? We're not changing the problem. 1 times that thing is itself. The trick is to use 3 over 3. But 3, this 3 at the bottom, instead of putting it here, you can move it around and put it in the front. And that's what they're doing. And why do they put 3 in the front? So that you can match these things. But we have an additional 3 in red color. We have that extra 3 right there. Okay, so basically this is, you're going to put 3 outside of the bracket. Do you see that? And why is it important to match those two things? Because this whole thing, according to this formula, this whole thing will become what? 1. So it's 3 times 1, which will give you 3. Okay, how many of you guys follow what we just did? Okay, about half. Okay, that's not bad. All right. So again, pay attention. You can watch the video later on. It's always better to just pay attention to what I'm talking about and just follow along, okay? All right, again, for this one, according to this formula, these two must match. But I can tell that these two are not matching. So what's the trick? You multiply top and bottom by 7. Why do we pick 7? Because of this right here, 7. Does that make sense?
Yeah.
But you want to rearrange one of the 7. You want to rearrange this bottom 7. Where do I want to put that bottom 7? In front of the x, and that's what they do right here. And so that you can match those two. But we have that additional 7 right here in red color. That extra 7, we need to pull it outside of the bracket or parentheses. Do you see that? But according to the formula, this whole thing, according to this formula, that whole thing is equal to what?
0.
0. So it's 7 times 0 is
0.
0. All right. All right, how many of you guys got what I just said now? All right, about the same amount? Okay, let's go to the bottom. All right, this is where you need to use some of your trig identities. I hope you guys know that. I hope everyone knows that tangent x is same thing as sine x over cosine x. You guys know that?
Yeah.
Okay. Well, for this particular problem, there is no formula for that. There is no formula, right? Remember, we only had 3 formulas. 2 of them were sine, sine, and then the other one was cosine, wasn't it? There's no tangent formula. So it doesn't mean that we can't do it, but we know that tangent 2x is sine 2x over cosine 2x according to this formula right there. Does that make sense? From the trig identity. But this can be written as, remember, this is a fraction over a fraction, so what do? You multiply by the reciprocal, which is 1 over x. That's why, and you put x in the front, that's why they have that extra x down here. Do you see it? And you can separate this. All right, they're skipping a step. You can separate this to limit x goes to 0, sine 2x over x times 1 over cosine 2x. You see that? You can separate these two, just like that. Why do I want to separate into that part? Anybody have an idea why I wanted to separate into that part?
It turned into 1.
So that I can change it to one of those formulas, right? But what's wrong with this circle part? There's something wrong with this, right? There's an error. What's missing?
The bottom top.
Yeah, we need to have a 2. We can't just put 2, so what's the trick? You need to multiply top and bottom by 2. That's why they have this. You need to multiply top and bottom by 2, only to this one. If you multiply 2 and 2, you're going to put 2 in front of this so that you can get this right here. You see it? But we have that additional 2. We can't just erase it, we got to put it with the other part. That's why they put 2 with the other part. Okay, according to your formula, if this thing goes to 0, what is sine 2x over 2x? What is that? 1. So since this is 1, you only have this left over. That's why they have this right there. You see it? So now they're using direct substitution. What is cosine 2 times 0? So this is 2 over cosine 0. But we just talked about cosine 0. What is cosine 0 according to the unit circle? 1. So this is 2 over 1. So therefore this is 2. And there it is. You can tell that we're using sine 0 today and cosine 0 today. Later we'll be using some other values. Okay. So I just went over 3 examples. I'm hoping that you guys can do this. I don't know. We'll see. All right. So like I said, I'm going to record this and I'll post it today. All right. So go ahead and try number 1 on your own. Let me pause this for a little bit. All right, here we go. Anybody have an idea what we need to use as a trick? Are they matching?
No.
No. So we need to match them up. Anybody have an idea what we need to do to match them up? Multiply top and bottom by 1/2 and 1/2. That's the trick. So what do I put this bottom 1/2? In front of it right here. And this one goes away because you put it in the front, but this one doesn't go away. This one stays. So are they matching now? 1/2 x and 1/2 x. If they're matching, what is this whole thing equal to? 1, and we still have that extra with what? 1/2, so your answer is 1/2. And check underneath. 1/2. There it is. You see that? Okay. All right, I'm going to give you a few seconds to work on number 2. All right, and then we'll look at it together. Let me pause this. All right, so let's go back to number 2. Here's number 2. Do we have this formula? Is there such formula where x times cosecant x? It's not one of our formulas, is it? No. So we need to use a trick. Anybody have an idea what we need to use?
1 divided by sine.
Yeah, so cosecant, you're supposed to know that cosecant is 1 over sine x. How many of you guys knew that? Okay, that's the trick. So you want to rewrite this as limit x goes to 0. This is x times 1 over sine x. But isn't this same thing as x over sine x? Right, x times 1 over sine x is the same thing as x over sine x.
Yeah.
You see it? It's the same thing. So are they matching now?
Yeah.
Yeah, they're matching. Isn't that your second formula, part B, isn't it? X over sine x. So what is this equal to?
1.
1. So this is equal to 1. And you can check your answer. It is 1. All right. All right, let's try number 3. I'll give you a few seconds to do that. And then after that, I might let you kind of do this on your own and see if you can figure this out, okay? So let me pause this. Pause it. All right, let's go back to number 3. All right, so there is no such formula as sine 2x over sine x. So again, you need to do something to this. Anybody have an idea what we need to do? You need to separate this. You need to separate them into sine 2x over 1 times 1 over sine x. Why did I separate it into sine 2x over 1 and then times 1 over sine x? So I'm ignoring this one, okay? So I'm going to just concentrate on this. What am I missing? 2x. So what I need to do is let's just concentrate on that. I can take sine 2x over 1 times 2x over 2x. Does everyone understand why I need to multiply top and bottom by 2x and 2x?
Yes.
Okay, what am I going to do with that bottom 2x? What are we going to do with that bottom 2x? Don't we move it here to there? So I'm going to move it to there, 2x. So what does that become right here? Isn't that 1? So now, so far, what do we have left over? Just 2x, right? So far. Okay, now I need to take the second part, which is this one. So I'm doing work separately. I have 1 over sine x. So what's the trick? What do I need to multiply top and bottom by?
X.
X. I need to multiply by x over x. Okay, which x am I taking and moving it over to where? Am I taking the top x or bottom x?
Bottom.
Top x. I'm taking the top x and then move it over here.
Oh, my bad. Yeah.
Alright, so what happens here? What is x over sine x? 1. But we still have this x left over. So what do I have left over as my limit? What's left over? Isn't it 2x over x?
Yeah.
So can I reduce 2x over x?
Yes.
Which is?
2.
2. So let's check. Number 3. Answer is 2. Alright, I feel like we need to practice a couple more. Alright, go ahead and try number 4. I'll pause it. Alright, can someone volunteer to help me out with number 4? Anybody? Okay, go ahead.
So number 4, you are going to, you're missing the A.
You're missing A. Okay, so?
Multiply top and bottom by A.
Very good. You multiply top and bottom by A. After that?
So then it becomes AX at the bottom.
Okay, you're moving this AX over here.
Yeah.
So this is sine AX over AX, and then times A outside. It doesn't matter where you put A. You can put it in front or behind it, but don't forget to put limit in front of it. I was just lazy to write down the limit. Okay, so what is this? What is sine AX over AX?
1.
1. So what is your final answer?
A.
A. Very good. All right. So how many of you guys feel comfortable with this? Raise your hand. Okay, I'll be walking around. So that's it for your lesson. I'm going to be walking around. Go ahead and try to solve the other ones. All right? So let me start recording this.